Okay, but yeah, today we're talking about building scalable and secure web applications with serverless architecture. Serverless architecture is a very big can of worms to open. And some people make entire careers out of a tiny part of it. So today, just to expect, what we're going to be talking about is kind of an overview, kind of the highlights of it, and then some of the best practices and some demonstration and use cases for serverless. Just moving along, who I am, I'm Michelle Tabor. I have not put up my job title or where I work on purpose because I've worked really hard to decouple my identity from my job for the last year, but just so you know, I'm a solutions engineer at a HubSpot agency. My job is to know a little about a lot and to make designs for people's data moving back and forth between systems. Always accepting LinkedIn or GitHub people. And the picture of me, I moonlight on the weekends as a race timer, have been for 5 years now. It is race season, so if you are in the running community, you'll see me out on weekends. And usually I look like this in sweatpants and a tank top or a t-shirt. All right, so today, serverless. Got a lot of topics to cover. Hopefully I fit it all within the time limit. So we're going to go over what is the serverless architecture, how it benefits web applications, challenges to using it, and things to think about when you're deciding whether to go serverless, monolithic, or microservices, how to design for scalable and secure, deploying and managing the security and compliance, monitoring, debugging, and performance, and then some case studies and some examples that we got. So, what is serverless? Serverless is a cloud computing model where the cloud provider manages your infrastructure, which means AWS manages your servers, your nodes, your droplets, whatever you want to call them. They spins up and spins down as your resources are needed, instead of always being on and always charging you money. So the highlights of serverless is it is event driven. The functions are evoked when they're needed. It's not on a cron job. I mean, you can put it on a cron job, but they are invoked and ran when specific triggers happen. It could be anything from an HTTP request, a database change, a file upload. You can do scheduled tasks. There's a lot you can do that triggers a serverless function. And so the cloud provider scales up and scales down as needed based on those triggers. So if you have 10,000 users come in at once and at noon and then none at night, it scales up and down as you need. So it says it's an ephemeral compute resource. It's dynamic. I think I've talked about that as just a second there. But you developers, that's a thing. You don't have to know about servers, how they spin, containers, blue-green deployments. You don't need to know about any of that. You just put it out there in a function. And the biggest difference between serverless and other methods of architecture is that it's on a pay-per-execution model. You are only charged for the resources that you use when you use them. And it's usually how much memory and how long it took. Different providers have different methods of doing it. And so then kind of what the difference is between the traditional monolith architecture, microservices, and serverless. A lot of us, we start out, we work in monolithic. We have a front end, we have a back end, we have a database. You know, you got your React, Mongo, and they talk to each other. And then you gotta get a little bit bigger into microservices where you have your front end, and then you have different microservices spun up for different parts of your app. So the load is distributed throughout based on need. And then serverless kind of breaks that up and abstracts it away, where you have your function, it goes to the client, and then everything is behind the scenes. And then you connect to a lot of different services as you need them. And then they're temporary, automatically scaled and based on execution time. So So a lot of use cases for the event-driven are real-time processing, asynchronous tasks, and scenarios with unpredictable or sporadic workflow loads. And like I tell a lot of my clients, which architecture you should use is depending on your purpose. What are you building? Who's using it? What for? Sometimes monolith is okay. Microservice performs better sometimes, so it's all up depending what you're building. So what we're doing, benefits for web applications, like the automatic scaling, it handles a lot of traffic without anyone having to do anything. You don't have to worry about making a new server or spinning down that server when you're done with it. So this allows developers to completely focus on writing code and building things. You're freed from maintaining all of those things, provisioning different iOSs or virtual machines, anything like that the developer doesn't have to worry about. They just don't. So it also causes less operational overhead, so you don't have to hire an IT guy to manage it, or a back-end guy. And so this kind of makes it a little more cost efficient. I forgot to delete my template piece. But yeah, the granular model offers cost efficiency by eliminating the need to pay for a lot of things that the cloud provider takes over for you. So it makes serverless really attractive to small businesses and startups because you can get more for less money when you're starting. And then just want to point out that serverless is fundamentally different because you don't have to manage your infrastructure. Right. And speaking of infrastructure, so it lets you focus on actually coding by taking away that infrastructure layer, and you can focus on code to solve business problems. They automatically scale. I feel like I'm repeating myself. Sorry, I have notes. So when you don't have to do that, you have faster development cycles. You can test, iterate, deploy, retract, redo it in faster cycles. You don't spend 6 weeks working on a feature then to find out it doesn't work like you want it. So you can test it out, deploy it, see it come back. So that just makes everything move just a little bit faster. But with this comes some considerations and challenges that you have to account for. There is a thing called cold start latency. This is when your functions have been dormant for a while, they're not being used, and then so there's increased time for response when you call them again. So that first time it does that. You get locked into a vendor in an ecosystem. You're either AWS, you're Azure, you're Google, or any of the other ones out there. And a lot of times you get stuck with that vendor in their methods, so it's kind of hard to get away from it. You also have limits on execution, duration, and resources. Even though they do scale, they do put resources on there, like your script can only run for 15 minutes. You can only store 6 megabytes internally. Things of that nature. It completely depends on the platform you're using. Those are just examples of the limitations of the platform I use at work. Okay, and then monitoring and debugging, that usually doesn't come built in. You have to build it in. You have to, install Datadog, put all the console logs, everything. You have to build that with these because it doesn't come standard. And then it introduces new security considerations, because a lot of these are run off of URLs that you use to trigger it. And you have to have, source. Oh my gosh, what's the word for that? You gotta verify the source of where it's from. Who's sending the call? Is it the right data? There's a lot of validation you need to be mindful of and make sure that they're secure from injections, or people can get to your hooks at any point in any way. So, and then one thing I didn't look in here is, even though you gotta sometimes watch for loops, if you're stringing a bunch of them together, you can infinitely loop your serverless functions together, and then that gets expensive. Don't ask me how I know, but I think we've all kind of been there. It can get almost just as expensive as spinning up a server and forgetting to turn it off. So some ways to mitigate these challenges. There is a method called warm-up techniques for your things to minimize the cold start. It's like you just call your function every now and then so it doesn't go cold. And yeah, hold on. I lost my place. Oh yeah. Warm-up techniques, call it every now and then. Use the provision concurrency features on your platform. They allow developers to like dedicate certain, like a minimum amount of resources so it's not completely dead. And then make sure your code's optimized. Big long pieces of code are going to take longer to start up and run from absolutely nothing. So if you can minimize your code packages, the overhead, and optimize the dependencies, there's a lot less for it to start up with. And that vendor lock-in, that when you get into the enterprise space, even slightly bigger small businesses, you get stuck in an ecosystem. You get stuck on AWS. And there are ways to manage that, like making cloud agnostic functions or containerizing. Is one of the pieces of microservices that is adopted in serverless is you can containerize, and that helps you port your code back and forth. And then addressing the execution things, we want to design for scalability. So this means like breaking it down into smaller functions of don't have a giant function that's going to do all the things. Like my motto is one function, one action. And then you could put them together, and then that also lets you have different pieces you can reuse in different places. And make sure you're allocating any resources that you are dedicating to it appropriately. If you know your app has like only 5 users, don't set your minimum standards to be for like 100. And then one of the things that a lot of people don't do is they don't implement retry and error handling, which is kind of important. Because a lot of times we think in serverless, oh, this is event driven, I'm going to get this data, then I'm going to do this with it. But it doesn't always come to you like you expect it, and it doesn't always go where you expect it to. So having retry functions in there or catching those errors and sending it down a different path will help timeouts and from things completely breaking. And then a lot of times you can add those with your logging, and then you get alerts in Slack that tells you something broke, I have to go fix it. And then, yeah, so that comes with the enhanced monitoring and debugging. The logging is important. Like I said, we use Datadog, and it tracks every single call for every single thing that's happening. But then you should, so use the third-party apps for that, because that's their business. That's what they do best. That's not what I do best. That's why I'm using serverless. So those are the things. And then there's another thing I don't know a lot about, but I found it in my research called distributed tracing. It's open telemetry. I've seen that thrown around. Amazon X-Ray also has that. So these are ways that you can trace the logs to help you debug. And then for the security and compliance, it's like following the best practices that we have in all of our other ways of like encrypting the data, least privilege access controls, and like regularly updating dependencies as they go out. Right, and then make sure you're regularly doing security assessments, check them, test them, and then because serverless is a favorite among small businesses, you may not have someone that is a security guy or gal, so you can pay third parties to do it for you. I'm all about pay someone else to do it. I pay the expert. So into designing scalable ones. So some of the best practices. I spoke about this. We want to introduce modularization, break it down smaller pieces, like specific functions for specific uses. You can implement microservices within serverless to do it that way, so it makes it even more abstracted away. And then kind of just adopting the mindset that this is event driven. So that's sometimes hard to get, or at least on my team with my experience, because I work with developers that are way more experienced with me, and sometimes they have outdated best practices, and event driven has been scary for some. So event sourcing, we want to capture and store the logs of events that change, like you need a change log, who's calling what, where is it coming from, where's it going, you want to log everything. Then access control. All right, so we talked about least privilege access. That's a fancy word. It kind of sounds just like it says. You get the minimum amount of permissions you need to do your job. I work with a lot of small businesses too, and then everybody's a super admin, and that is not safe. And then you want to like kind of use the IAM systems. People say that different, but defined roles. These are kind of like onto your admin, provider, IT guy, but making sure that roles are appropriately provisioned, and just managing access to that data in the user roles. So, and another way is to more things. Embrace immutable infrastructure. That term, I have actually just learned about this, and I really like it. This means nothing gets updated, ever. You deploy it, it doesn't get updated. You're not going back and you're not pushing to that. You are replacing it. You're only replacing it if it's better. So that way you have a clear change log, what went wrong, those types of things. And then, Right, so then we also, in that, we want to maintain, don't maintain state within your functions, don't store data within your functions, those types of things. Any persistent data should be stored in an external database, and then retrieved when you need it, especially if it's like a shared resource like config files, secrets, keys, those types of things. Definitely should be stored externally from your function, and then they should also be encrypted. So securing data in transit at rest, this is kind of more important nowadays because cyber attacks happen like every single day. So we want to make sure that you're transmitting data over secure HTTPS, TLS services, and you're encrypting it in storage at the source when it's moving, all these things, and then having a way to decrypt it when you present your data to your users. And then making auditing a best practice and a habit. Don't just make it, sit it out in the wild and never come back to it. Sometimes you need to come back, and users will surprise you with how they use things. I think we all kind of know that. But then you'll also find user insights, but you can also uncover security flaws by going back and auditing. Recently, we discovered that one of our endpoints had been discovered and somebody was using it to test credit cards against because it was a payment server. And they were doing it with a human, sitting there typing it because of how often it was, but they kept using the same name. So we were able to do that just by going back and maintaining audits and looking at what's happening. So, moving on. Considerations for data storage and state management. Data storage. Like always, choose the appropriate solution based on what you have. Does it need to be SQL? Can it be a CSV? Can it be a SharePoint? Is it a MongoDB? Those things is kind of based on what you're storing and where, whether it's unstructured or relational databases, things like that. There are so many options here that I default to SQL and Mongo, but that's just the nature of the business I'm in. But you have this, and then you want to also consider data partitioning of, indexing, caching, different places and strategies. You don't want one huge table with everything for your business. So just making sure you actually have a data strategy in place for your storage also makes it easier when you're pulling data out of those databases to access it. Right. And then I think I did talk about state management. Design these functions to be stateless. It does help them scale faster and helps them not error out in case an API key goes wrong or something like that. And then you want to use the external data stores, and then a lot of these platforms have caching. You want to use those. You don't always want to pull raw data every single time you need it, especially if it doesn't change very often. You can cache those using Amazon, was it Elasticache or something like that? So, and then just want to make sure you're applying like consistency across your data. And your state management. You want to use the same processes over and over. You don't want to change, especially in smaller businesses. One person likes to do it this way, one person likes to do this. You got to have it the same, and then adopt those across the entire app that you're building or company. All right, so deploying, managing serverless applications. I want to go over the big platforms of like what they're used for and how they're very similar. So the big one, AWS Lambda. This powers a whole lot of the internet. And these are the tools that AWS has available to use, is the management console, the command line, SAM, CloudFormation, these things. So the management console, if you don't use the command line, you can put all your code in here. You can manage it from the browser, deploy your code, set up all the things. But there's also the CLI that lets you do all the same things from the command line. And then SAM is open source actually, and it actually provides a framework for you to define your dependencies and lets you package and deploy your thing. So management lets you put it in there, and then SAM lets you figure out how you're getting it out into the world. And which CloudFormation is an infrastructure as code service, which is a field that I don't know anything about, but I know it is a part of this. But I know that it does let you manage all the underlying things. And then you have third-party continuous integration, continuous deployment tools that work with AWS. A lot of people use Jenkins to automatically deploy things when they're on a schedule. And then Azure. Azure is another big player in the enterprise space, but they do about the same thing. You have your web browser, your command line, your tools, and then your deployment. And it's the same thing for Google Cloud. I do work with some enterprises that are on Google, but the general consensus is it's not as mature yet. But they have the same tools, and I've built on it, and it's the same as anything else. And then there are other platforms out there that are smaller. I personally work on HubSpot that has its own serverless, and Tray, which is another platform as well for anything that's outside of HubSpot. So you can see this in a lot of different places. All right, so we want to ensure consistency, reliability, and reproducibility of deployments. So we want to make sure everything that we make is the same, deployable, and we can do it over and over and over again. So that actually gets really in the weeds with managing your dependencies. Those are, all the things that are in your yarn.lock file or your package lock file. And that also comes with, oh goodness, sorry. Yes, package.lock, whatever. Okay. And then consider using virtual environments or containerization. This is one of those things that helps you port across different platforms, but also helps you maintain consistency because you can make sure your environment is the same wherever it's being deployed at. And then also invoke versioning, semantic versioning, major, minor, patch updates. All those things, source control, make sure you're using Git. Nothing's worse than making a change and then having it break and then not being able to go backwards. So I feel like sometimes these are common sense, but sometimes they're not common sense. And then this one here is something I've been trying to build at my company, is artifact repositories. These are packages, things that you use over and over again that's outside of the actual app, like things that you use to spin up a template or things like that. So you can make sure you have these resources for everyone to use, so it speeds up time and gets you coding faster. Then your environment, make sure your environment configures are the same. Store, you have like secure storage for your environment configures. It's like a .env or secrets. And then parameterize, that is a word, configuration settings. All right, so the way we do this in some of the integrations I work on is there's parameters that get passed in to set up the integration, like account keys, there's account tables, things like that. So things that do not have to be static should not be static. Don't hard code a table name in. And then there are tools to help you do that. AWS has the parameter store. Google Cloud has Secret Manager. These types of things. So you store those externally and then pull them in. And then also adopting the infrastructure as code helps you manage the environments that your items are being deployed in. And then also having an actual deployment pipeline helps you do that as well, because then you set it up and it helps you do that. Ensuring security and compliance. We talked about this, data encryption and transit at rest. This is a very big thing at where I work because we deal with so much data, everybody's personal data all over the place. You could assume entire identities. So you want to make sure it is being transferred securely, stored securely, everything is encrypted. Right. Key management, we did just talk about key management. Right. So then, yeah, so we want to make sure it's encrypted. We want to make sure our security, we're following best practices with the identity access, who can access what. And then also manage our vulnerabilities, because nothing is 100%. You should regularly be having like a dependabot scanning for your dependencies, making sure that they are up to date. There's no vulnerabilities there, making sure that patches are getting pushed out. And then also just being aware and informed of changes that are happening, like between versions of things as they come out. That goes a long way of just someone raising their hand and saying, hey, there's a new version because this past thing doesn't work anymore. And then also making sure anything you build is in compliance with the government and any other regulatory people. I know a lot of us hear about GDPR and HIPAA, but there's other ones that you have to think about, with like FINRA and the finance, and SOC 2 is important as well. So just making sure we have things in place for that, ensuring that we have logging actually happening, and then making sure we're actually checking our code and our apps for security. So some tips for some strategies for making this secure is securing your sensitive data. Data classification, this is classifying your data, of course, of like regulatory requirements, what's confidential, what is not, depending on, level of risk of like, how do I store social security numbers versus favorite color? Those are different things. Well, favorite color is bad because that's a security question, but categorizing these things so we know and where they're stored, and then also only storing the minimum amount of data that you need. I do work in marketing, and in marketing, the more data is better because everyone wants to know that your favorite color is blue without talking to you, so they can advertise to you. But when you're building apps, you want to maintain the least amount of data that you have. You want to store what's going to make it work. Making sure we're encrypting and masking and reducing data. Like, we deal with payments, and we get people's raw credit card numbers coming in. So they have to be encrypted and redacted, even if they are like encrypted in transit, but when we're trying to debug and they're like, okay, what was the last 4 of your card that you're using so we know where it happened? You have to be able to mask part of that. Even if you pull it back up out of the database, the end user doesn't, the customer service rep doesn't need to see the whole thing. Then you want to manage your secrets. We've talked about this. All of the secrets stored separately using external tools or internal native platform tools. And we want to make sure that those secrets are being rotated at least every 6 months, even though there's debates on how often you should actually rotate your API keys and your secrets. But it is important because they do get leaked, and then bad actors will infiltrate your systems, which is another reason why you should implement a zero trust policy. Every endpoint, no matter if it's been pre-authenticated or not, should verify and validate before it goes and does something. Right, and so there's also the defense in depth principles of network security, app security, runtime, and container security. These things I'm putting out here in the world because I know they're important, but I don't know a lot about them. This is kind of the part of I haven't got to yet. And then want to put out there is the continuous monitoring services that can do all of this for you. And some of those services are, I made a list so we can just go look them up at ours as we want. Cloud native tools, CloudWatch, Google Cloud Monitoring, third-party Datadog, which I see a whole lot. And then you have distributed tracing, X-Ray, Google Cloud Trace, OpenTelemetry. And then debugging, there are the cloud, like the platform native logs, and then AWS and Azure and Google, they all have local debugging tools, so you don't have to like push your code up and put it live in the world to see if it's going to work or not. Or you can also pull it down and debug it when you have to run it like 50 times to find that one instance. So, and then there's also remote debugging tools, and this is for like really big teams. All right. Then we'll talk about some real world use cases, and I got some Netflix. They are on serverless, only partially. They have went back and forth between serverless and microservices for a while, but right now, Netflix is using serverless functions for their video upload, storage, and encoding it. So when a video gets uploaded to Netflix by one of their publishers, it goes to an S3 bucket. It gets broken down into 5-minute chunks and then encoded and put into different streams for people to watch. And then they use it for system backup. They constantly constantly look at their files to make sure they're not corrupted, that they're correct, and if any chance that something has gone wrong, they have lambdas that are running in the background to go retrieve a backup and restore it so people don't know, and it's all running to make sure we all enjoy our Netflix. And then Netflix uses them to manage your accounts. Like, do you have a valid account or not? They are constantly spinning up new Netflix instances or spinning them down as people cancel. And then they shut them down if someone has used, somebody else's password. That's what Netflix uses them for. And then so there's other big players out in the world is Airbnb. They actually have this project that is 95% done, and it's all built on serverless with this map here, which I found really cool. Airbnb, we think hotels, but this project that they're releasing is a data analysis framework that's meant to connect you and analyze data from any source. And I have, when we share this later, I have links to these if you all want to go look at them. And then Capital One, their entire business just transferred to AWS with a serverless first approach. They have thousands of counts, tens of thousands of Lambda functions, like the everything that Capital One runs on is with a serverless function. And then I read a case study, and I just put this in here. This is like best practices. They have just found out during their implementation of their size, since they're global, of how to use it for that scale. And then one of the biggest things they said was using the use of thousands of counts, because they have all these distributed business lines. They're not all in one AWS instance. Like every single little tiny instance of a Capital One business line is its own AWS account. So that also helps them with, user provisioning, making sure you don't have access to the whole system, and it runs faster. So I did have a AWS demo of like what AWS Lambda function looks like. Can I pull this up? Yes, there it goes. So this is what Lambda looks like when you're deploying a function. This is using the console, and this is just a very simple function that reads the file, the HTML file I have over here, which is just the basic Amazon demo. So when this file is called, it just returns 200 and the HTML file. So here is the execution URL. So when that hits, no internet. Oh no. Oh no. Hold on, let me reconnect.
400.
Oh no. There we go. This is returned. This is the HTML file that we had stored. So that's just the basics. Just the basics that we have. But they can do a whole lot more. Then I want to show you. Nope. What it looks like in an advanced version. This is an app I've been working on for a rental car company, and I did it for a boot camp because I just finished one of those. Within HubSpot, they have cards that runs little React apps and little containers. So every app is containerized on their platform across, there are thousands of customers. And within those, we have our own serverless functions. So here we have 4 functions because we're working on rental cars. And then you can call external services. This is a geolocation service. We're calling Google to find out how far away these cars are from where the person's at. So they have these. I should have pulled this up. 1 second. I'm sorry. Security. So this is what this app does. It finds a car, And that was the geocoding running, is found all these cars this far away. And then every action is a serverless function. Well, it's not like handled by React. Where's the next? Sorry, it's hard to see over there. All right, so then that get vehicles was the code of like, here, find all the vehicles that match these parameters. So every instance that is a function. And then booking, you can confirm it, like if you make it go, like, yes, I want to order this. Yeah, I add gifts. So like it created a booking, so this makes, if it took all the information that we passed to it, like we're passing information from function to function, and then creates a booking, which in HubSpot is a deal, just to say, yeah, someone bought some money. So that is an abstract, bigger way that serverless functions are used. And that is the end. Do we have any questions?
Business, so.
Yeah, you can pull those in too.
Yeah. Can we get the slides?
Yeah, I will share the slides in the Slack because it has links to, there's a couple articles I found that were really cool that went way more in depth on some of like the infrastructure as code that I didn't want to, I distilled down as much as I could, but I have links in there. I will share those slides in our Slack channel.
Thank you.
All right. Thank you all for letting me do my first big long talk here. And I made it through.